Now, I would like to introduce our next speaker, Tandunkar. He is a Principal DevOps Consultant at NTT Data UK with a passion for digital transformation, leading both technical and cultural change for clients. He's a cloud native enthusiast, and he's currently leading technical teams in their adoption of DevOps principles, introducing new concepts and technologies to accelerate software delivery. Welcome to DevLab, Ram. How are you?
I'm good, thank you. Thanks very much for the introduction. My name is Ram Tandukar. I'm a Principal DevOps Consultant at NTT Data, and I'm very happy to be presenting today at DevLab. I know I've only got 30 minutes, so let's get on with it. Okay, so the summary for the presentation is notes on a cloud migration. And I just wanted to use today to share one of our recent experiences as a part of a cloud migration, helping one of our clients move from an on-premise data center to AWS. So very, very common. And for this particular client, I guess that their main approach was more of a lift and shift style, which is not uncommon, and especially for organizations who are looking to move to AWS, as much as they would like to spend the time to do a full kind of cloud native migration, it's not always possible. They've often got time pressures to get out of their data center, which was the case with our client, and they they usually, there's like might be a lot of development effort and stuff to go into it. And I think it's a balance, right? So, we definitely found with most of our clients who are going through this transformation that, you need to make, sometimes you need to cut corners to make sure that you can make your migration dates. And in this particular case, what was quite interesting was that 90% of the services were targeted to be containerized and migrated to EKS, which is probably quite rare in regards to, you usually have a little bit more of a mixture between having, some maybe moving to EC2 or maybe moving to, to more traditional style VM type setups. But in this case, we were able to containerize many of the applications that they had, and that was the target, to simplify the way that they manage their applications in the future. Okay, so that's a bit of background, and now I'm just picking out a couple of problems, and I had 3 or 4, but I'll try and limit it down to 2 given the time. And in this particular one, so the actual, as a part of this migration, what we found with one of the key applications in their stack was that they were using non-standard DNS names when they were referencing their databases. So they wrapped their applications up in a number of reverse proxies, and these reverse proxies made it easier for their configuration to configure each environment, so that they could just refer to appdb, right, and it would get to their database, right, and they could move the application from one environment to the next, and that would work out quite nicely. But the problem is, that they hadn't obviously configured the applications in a neater way, so that they could easily change this underlying configuration when they wanted to move to the cloud. And one of the key issues that we ended up having was they were using stuff like underscores in their DNS name, like this one, app_db, and obviously this is not directly compatible, especially with the service names in Kubernetes. Okay, but also, going by the RFC standards for DNS, underscores are not allowed. I think maybe in the past they were accepted. But yeah, it's it's definitely heavily discouraged now. The other point around this is to refactor the existing application and to make a lot of core changes to their, I guess, their core configuration. They decided was too risky and it was going to take too long before the actual migration needed to occur. So it was quite, that's obviously quite an important part, because ideally you would make these changes to these sorts of configuration before you moved. And the final one was that, it was really critical that they could obviously roll back seamlessly the same application stack without making any updates or anything, so that they could deploy the same thing into the cloud, but also roll it back quickly into their own existing environment. Okay. So solution-wise, so we actually had quite a lot of time to we took quite a lot of time to think about this, but luckily we attacked it as one of our first design issues. And we took some consideration, we did quite a bit of research, and the solution that we came up with was to use core DNS, which might be known by many people as now running actually cluster DNS. So I think it's kubedns has been around for a long time. Slowly, core DNS is becoming more popular as the DNS tool of choice. In this particular case, what we thought was a kind of the best solution was to run core DNS inside the actual application pod itself, along with the application container, redirect the DNS resolve so that it was pointing to the core DNS. And luckily, core DNS itself was happy to accept the non-standard DNS, so that we could configure each of the particular applications with particular rewrite rules to then forward it to the right location. It would also obviously then forward anything that didn't match those rewrites back to the standard cluster DNS. I guess the other redirect. Sorry, the last point is. Oh yeah, so the other point was that everything was so obviously you could do these rewrites maybe on the cluster DNS side, but the actual rewrites themselves were contained within the application pod, which was critical in the end for ensuring that we stayed as isolated as possible when we wanted to make the changes, and also so that we could make the changes and then after the migration was completed, that you could actually change the configuration of the application and then update, and then remove the actual the actual core DNS part whenever you required to do so. Okay, so let's switch and actually look at some of the configuration. So I know I'm kind of feeling the time criticality, so I'm not sure how much of a demo I'll get into, but I'll show you the configuration because that's maybe even a little bit more interesting. So the first thing is what we're looking at is a Helm chart, and this is one of the a part of the I guess the core part of the solution, right? So when we're creating our deployment of the application itself, so the first thing that's important is that we need to make a change to our resolve.conf. In this particular case, we're in our pod environment, okay, and we need to reference the core DNS pod, which is going to be running within that same container within that pod. So in this particular case, we can use the loopback address. It's going to be listening out on 53 UDP port. So we know that if we target the loopback, that it will come back into the into the container, into the core DNS container. So again, this is a temporary solution, and again, obviously strategically, it's not something that you want to keep necessarily around for a long time, but it was a workable solution. And then as far as core DNS goes, we add it as an additional container. So there's a couple of points around this. So the first thing is where we've got our core file, which contains the configuration for our actual, they call it the plugins for core DNS. But importantly, in our case, for redirects, and we're mounting that as a config map. Within the config map itself, then, we can define our sidecar rewrites. So in this particular case, again, some Helm templating is going to be inserting our rewrites, and then within our values file, we're able to rewrite our non-standard DNS name to our to our destination, in which case is a longer DNS. So this is quite effective in ensuring that we can rewrite and manage our DNS effectively with these within this particular environment, and we can push all that configuration into our values files as such. Okay, so I'm doing okay for time, so let's move on to the rate limiting issue. So another area for, I guess, that came up as a as a potential issue. Well, not so much a potential issue, but an area that we felt like we needed to improve was the rate limiting. So again, with this particular client, they were connecting to some legacy services upstream as well. So for those who might know what SMPP servers are, but they're often within the telco infrastructure world, they're obviously almost a legacy, often legacy driven infrastructure that sits behind these, and rate limiting is quite common, right? So they want to make sure that they protect those those particular systems and servers from getting overloaded, and there were contractual obligations in place as well to ensure that this was deployed on the client side, not just necessarily on the server side. What we found was we were using Istio, but what we found with Istio that the rate limiting is quite clunky. So number one, you have to write your own envoy filter, which can be quite difficult for the platform team to maintain. And we were looking for a more effective solution. So as you can see on the left-hand side, in this particular case, the application was limiting down to making only, say, 5 requests per second or something along those lines. Okay, so on to the solution. So HA proxy I think was probably written around 20 years ago, and I remember using it in the very early days of working with Linux, which is probably showing my age a little bit, but it's for those who don't know it, it's a very fast, high performance and reliable reverse proxy, and it's used for many other purposes, and becoming more and more popular in the cloud native world as well, probably ideally because of its high performance. The configuration of the rate limiting in HA proxy, I think, is comparatively simple compared to Istio. It's a little bit more, it's the way that it exposes it, and you probably see that the way that the configuration is exposed is quite similar in a way to the way that that Istio is as well, the way that not Istio, the way that core DNS is. So it's got a base configuration file that can be easily used to kind of gather details and store the file, and then and allows you to configure it easily. And in this particular case, we let it run through the Istio proxy and out through the Istio egress gateway, and then we added the rate limiting or the HA proxy at the end of the stack. So this for a couple of reasons. So firstly, within the Istio stack itself, we didn't want to impact any of the connection limit configuration and other kind of like Istio level configuration on the destination rule that we might have put in place. Also, obviously, if you're doing a rolling deployment or canary deployment, you probably still want to ensure that and you've got multiple instances of those applications. You also want to make sure that you're limiting for all those connections. So, pushing it any further left towards the application pod probably wouldn't be appropriate. Okay, so let's have a look at the configuration as well for the SMPP. Okay, so HA proxy itself, there are various Helm charts out there, and obviously, I believe HA proxy is also utilized these days as an ingress controller and in an enterprise fashion as well. But this is, we've just picked one of these up from, from a Helm library, and what we're doing here is we're able to configure the actual config map, SMPP config map quite quite easily. So it uses a front end configuration. Okay, so this is basically defining how you're going to expose, or the port that you're going to expose to your from a service perspective. So and I'll show you probably the real example in a second in Argo CD, and from actually configuring the rate setting itself, it uses a configuration called stick tables. So these could be seen as kind of like buffers that store kind of connection information, or in this case, connection rate information as you're going through. Now, I've left this one quite high at 10 seconds here, but obviously you could push this into a values to make this, well, okay, the example that I gave earlier is 1 second. So 1 second, you can obviously specify what you want to do if that connection rate is greater than 5, in this case 5 requests. So reject if the connection rate is greater than 5. From a backend perspective, so got this idea obviously of a front end and a back end. On the back end side, defines what your target location is going to be. Okay, and go. So maybe I can just show you the configuration. So I think I know my where this is work. Oh yeah, that will work. Okay, so in this case, I've bound to a port 306.36, and my destination here is just a test SMPP server that I found. So okay, that's a good example. That's Argo CD. So that's an example of how, I guess, from a, it's another example, I guess, of how we've been able to fit in a solution into, the particular stack that we had. And in this particular case, I think that it was quite an effective solution, especially from a configuration perspective. It made the operations teams a lot more comfortable with configuring it in this way, rather than using a rather kind of more, let's say, complicated way of implementing the envoy filters and the various complexity that came with that as well. So that was actually the end of my presentation. I probably rushed through that a little bit too much, but the final thing that I just wanted to talk about a little bit, and I'll go back to the first slide, was, from a technical perspective, largely across, the shift, especially moving from an on-premise environment to AWS, but also from a traditionally more legacy setup regarding the way that they were deploying their applications into EKS. It was as much of a let's say cultural impact, and winning the hearts. And I know it's probably an overused thing, but this was a great example of, it was very much about, getting the buy-in from the various engineering teams who were involved in the migration itself, to move to a new technology like EKS. So AWS was one thing, definitely moving to Kubernetes and kind of bringing them along that journey was another as well. And I can't emphasize enough about how important it was for our team, and also for obviously for their teams as well, to really engage with the process, be very open with the way that they were, being open to learn new environments, and to a certain degree to unlearn some of the things that they've done previously. There's a lot that's talked about, the ability from a learning transformation perspective to allow yourself to be opened up to these technologies. And this was a perfect example of that, where slowly, I think, while we were there, the organization itself really transformed the way that they were moving and opening up to learning, I guess, a new sort of environment and style, and operations. So I just wanted to emphasize how that was another critical part of the process. Anyway, I've finished quite early, which might be a good thing, because I can we can open up for questions, and hopefully.
Absolutely. So thank you so much. I love how you came with the challenges and the solutions. I was actually wondering if you could share some basic DevOps roadmap for aspiring cloud engineers.
Yes, of course. So, from I'm not sure whether, let me just, so I can talk, not talking at my, switch back. Stop screen sharing. That's a little bit better. Yeah, of course. So, let's look. If I look at my own career and where I came from, so coming out of university and doing software engineering at university, I very quickly moved into the banking environment, and I guess I've always been interested in tooling. So I very quickly kind of moved into that kind of tooling space, and then when I moved to the UK, it was all around Atlassian tools, which, even though I'm Australian, I didn't really mean to fall into Atlassian tools, but yeah, Jira and Confluence, and I kind of that started my kind of like move towards the DevOps, especially more towards the DevOps field, let's say. And then, I guess migrating on, through those periods, I guess the key thing for me was, I was always keen to just learn that little bit more about the technologies and the underlying, let's say, the underlying complexity that comes with particular platforms. So be it with Linux, where, very early on, I was, always wondering, what was behind the kernel, and hacking away at, things to try and maybe make things or break things. So it was, I think, that sort of curious mind, and it continues to extend as you as you grow into your roles and as you mature as well. So even now, perfect example is where we're going to be working with a client on Pulumi, and Pulumi is we're primarily a Terraform, a team who uses Terraform a lot, but just very quickly, starting to develop that kind of knowledge around Pulumi, what it's about, starting to have a look into it. It excites me, and I think that that's the same for any techie. Let's call it techie. We can't really call it that anymore. But no, but really, I think that innate sense of curiosity. So don't lose that, and continue to kind of strive to find roles and environments that provide that for you.
Absolutely. I couldn't agree more. So Brendan from the audience, he said, great presentation, really innovative solutions to unique problems. How long did this migration take to complete? And what would you say was the biggest challenge along the way?
So that's a very good question. So firstly, the migration, and to be honest, it's still going. So the initial migration, let's say, so the build of the underlying landing zone and platform took around, I'd say, 12 months all up to be fully mature, which is pretty standard, I think. That was for the landing zone, the stack, the design and setup, and everything to kind of wrap around that as well. And then there are still applications that are migrating across now. So I'd say all up, it will probably take them around 2 years for a for I'd say a medium to small size organization. And I think, the biggest challenge was the fact that, there was always a difficulty in actually, I think that they had a few false starts with AWS migrations. So they tried, and then they kind of failed. Then they tried again. So there was a lot of skepticism within the organization about whether it would actually work or not. There was a lot of skepticism whether specific applications would work. This is actually a really good, probably, example or lead into it, which is, how can you build in this complexity? What about this sort of problem? The DNS issue did come up early on, and they were like, we won't be able to do this. But I think that it was very much a hearts and minds type exercise to get them on board.
Amazing. Thank you. So Govinda wants to know, what are the steps taken to securing the data?
Okay, so I think that from a landing zone perspective, and I'm assuming you mean from the broader perspective. So from a landing zone perspective, we had a core requirement around zero trust. So we were using Istio to ensure that even within AWS, which was, I think that the term was that AWS was still a hostile network, as in, we don't necessarily trust it. We ensure that we've got end-to-end encryption. All our connections from our, like API clients or customers and upstream as well, were all encrypted. All, from a security and encryption perspective, everything was fairly tight, even though we didn't have a lot of what we would call highly sensitive data, like credit cards and stuff like that, within the organization. Obviously, client data is still highly sensitive. But yeah, these were the key drivers for that as well. Encrypting secrets, of course, and effective secrets management. These were the key points.
Okay, thank you. And what advice would you give for a senior DevOps engineer who wants to get to principal lead level?
again, really good idea, really good question. So, and my team, I'm constantly coaching them and helping them along this journey, right? And I think the difference, well, the key difference that we have in our organization between probably a senior DevOps engineer and a principal is, number one, the ability to lead a team and effectively lead a team. So feel comfortable going into an engagement and, being the one for everybody to look up to, communicate and face off against, various levels within your client engagements. Secondly, business development. So you have to understand the business, and you have to understand how that fits in with your team and how it impacts the way that we work and the way that we see our clients. So we have some very strong, ideas around, putting our client first, ensuring that we build foresight and that we work as a team. And I think that these kind of core values from the organization also is what we focus on when we're looking to promote people to those positions as well.
Perfect, thank you. I'm very curious here. So basically, what I do is I coach people on the interview processes and I prepare them. So I was wondering, how would it be if someone were to apply for NTT Data UK? What would be the interviewing process?
Sure. So let's say you were interviewing for a senior DevOps or a principal lead. Most of the time, 90% of the time, probably a principal or lead would be interviewed by myself first. It's, I guess my interviewing process is, I wouldn't say it's a little bit non-standard, as in I'm more interested in people's technical competency overall, rather than necessarily a set of, do you know how to do something very specific in Jenkins or something like that. So a lot of our questions are more, bigger picture type items, maybe a bit more architecture based, or I try and get people to think. So I often use Git as an example. Now that I've told everybody that, what shouldn't be that. I've been thinking about changing that anyway, but I usually use Git. So everybody who's interviewed me over the last couple of years probably knows about my Git questions. But it's really the point of that is to get people thinking, right? So, and I want to see that people can effectively solve problems on the spot and think on their feet. And then, we try and keep it to a two stage interview process. Yeah.
Perfect. Thank you. Thank you so much. I wish we had more time. I'm sorry. It was great talking to you.
Okay, I finished early, so it was great to actually have a chat.
Thank you so much.